it, and I tried to. Alrighty, we are doing something called percent yield today. It is still 3-step math. These things do not go away. What I did with my cookie thing. There it is. And I know that when I give you the answers when we have work days, it helps. You can immediately know if you're doing it right. If you're not getting the right answer though, as long as it's, a few decimal points off, that's no big deal. That's a rounding issue. Or it's a sig fig issue because I round my answers to sig fig. Hell, if you're not getting the right answer, you're very quickly running out of time. To figure out what you're not getting, where it's not clicking. So we're still doing 3-step math, but now we're going to calculate something called percent yield. So how do you, yes?
I come up being stupid. Every time I close the power off.
Did you change something in your settings?
No, I just got this Chromebook yesterday from my other one. Or charge.
So it will not turn on at all, or you're just having to restart it every time you open it?
I restart it every time I open it.
When we get done with this, as long as you're not confused, I don't know if I'm assuming she's up there right now.
I don't know. I know she was here yesterday.
I haven't seen an email saying that she wasn't going to be up there. But this won't take long. Today's very, very short. I can send you up there. Figure out what the heck's wrong with it. All right. How do you calculate a percentage? How do you do this? Just in general? No. Don't even worry about chemistry. If there are 13 questions on a test, how can you figure out what your grade is? Yeah, there's an easier way to do it. I mean, you could divide 100 by 13 and multiply that by all the ones that you got right, but there's an easier way to do it. Let's say you get 9 questions right. It's a 13-question test. How do you calculate your grade? No. You take the amount you have, which would be 9, and divide it by the amount that you could possibly have gotten, which is 13. You take the real amount divided by the possible amount, and then you multiply it by 100. That's what we're doing, but we have to do a 3-step math in order to do this. In almost every type of problem like this. Now, I know there's one of these on the test because I looked at the test last weekend when I was building these. They're very, very, very nice to you with the percent yield, at least one of the percent yield questions on the test, where they actually provide you with the actual, which is going to be in the problem. This is how much you isolate in the lab. And then they give you what your theoretical would be, which comes from your math. All you have to do is take the amount that you really have, which is the actual, you divide it by how much you should have gotten, which is your stoichiometry answer. You multiply it by 100 and you have 2 numbers after the decimal. That's your percent yield. If you take chemistry in college, you should do the lab where you create aspirin, just like regular over-the-counter aspirin, and you use buccal funnels and like you actually make it. It's not like, anyways, you're graded, if you go to a really good 4-year college and you're going to take chemistry no matter what, you take biology and chemistry, you are graded on that lab by your percent yield. So the better you are at measuring things out, the better off your grade is going to be. And it's always a major grade. I remember doing this lab when I was in college. So when we do this 3-step math, that's how much you should be able to make. That is a theoretical yield. If you're perfect, you measure everything out perfectly, and you don't spill anything, and there's not anything stuck on the inside of the container, which we're not perfect, it's called human error. But if you're 100% perfect, then you're going to be able to make 100% of what you should be able to. We don't do that in real life. Okay, not that you're just throwing chemicals all over the room, but there's parts that will be left behind, specifically on the inside of the graduated cylinders or on the inside of the waybook. Your actual yield will never be, can't be, more than the theoretical. It's always going to be less for multiple reasons. which means your percent yield can never be more than 100%. It can't be. It'd be close.
Although I don't understand that side, everything's on spot.
You heard it in the wrong spot.
Yeah.
The actual yield is always going to be smaller than the theoretical. I know your parents say you're perfect, but I'm sorry, we're not perfect. We're not.
My mom is not saying.
She didn't say you're perfect.
No. She calls me from.
Oh! I tell my kid a goober all the time. She is. Now, if you get more than 100%, as long as you didn't mess up your math, okay, there's a possibility, like I still have people that are doing 16 for the mass of oxygen gas. It's 202, 2 times 16, which is 32. If you mess up your math, then obviously this is going to be wrong. But more often than not, you flip-flop them. So I know we've had a lot of time where we've been going over these 3-step mass. We've been doing it over and over and over. We've had a few different days for working on it. I'm going to give you yet another one tomorrow, percent yield, and I give you the answers for tomorrow's as well. We'll review for our test on Thursday, and the test will be Friday, and it's almost pure math. Do attendance while you guys can catch up. The answer is it's how much you have divided by how much you could have had. So it's what you earn divided by the maximum. If you're thinking of like a test grade. Okay, now I see what you could have made maximum. So like in the example I gave, if you made 9 out of 13 on a test, let's see, that would be, I'm sorry, I'm not going to math in my head. That would be a 69.2307669%. Okay, Alexis. So if you are still confused, and today is very, very, very short. I see Luke, Alexis, Valerie. We're going to have one more day tomorrow to try to fix it. That one's in here. George is here. Bailey, Tiffany. I just saw you, Luke. Does anybody know what is going on with Matthew Kemp? Well, like Matthew Kemp, like not. He's virtual? Okay, Luke says he's virtual, but he hasn't been showing up. Or does anybody know what's going on with Robert? Okay. No! Yo. All right, so anybody still need this slide? Okay, this thing doesn't go away. This is a stoichiometry conversion cross. I do have some people that are still using the factors, but they would do like the parentheses times parentheses, which is fine. Whichever way makes more sense. It's the same thing. So if you still do not understand this thing, you need to put this on this paper. Okay, so you're going to start with a given substance. Most of these are mass. So it's going to have a number. This is not a hashtag. This means a number, and it's going to be in grams. Do not leave the substance's formula off. So if you're starting in grams of oxygen, it would be, I don't know, 12.2 G of O2. Don't leave off the substance because you're going to get lost. If you start in grams, the only thing that you can change that into is to 1 mole of that substance. And this is going to always be a 1. Always. You have to use the periodic table when you see grams. Okay? You're going to be changing to a mass in most cases of a different substance. So you're going to bring the mole of whatever that substance is. So in my example would be mole of O2. And this is where people get lost. This is where you switch it into moles of something else, like moles of hydrogen gas. I don't know, U is what you're changing it into. You use the balanced equation here. Then you're going to bring down 1 mole, it's always 1, of whatever that substance is, and you're going to change it into its grams using the periodic table. This template does not fail a mass-mass conversion, which is going to be the most common one that you're going to see from me. Like I said, I normally don't make the tests. They come from the pre-AP chemistry teacher, actually. Those are always going to be a 1. If you have not done it, highlight it, circle it, write it in a different color, put a smiley face next to it or a star. I don't care. These two will always get a 1. The molar masses are going to have to be calculated from the periodic table. The periodic table deals with grams. And then the 2 that are in the middle, those come from the balanced equation. It can't be a 1, but it doesn't have to be. It's whatever number's in the front. Now, Ms. Youngman, apparently, like if you look at the assignment, like the top one, they all have the coefficient, but in the second problem, there's a 3, a 4, and then there's, these 2 don't have numbers, and then there's a 4 at the end. Some chemistry teachers don't put a 1 in the front for the coefficient. I do. So these 2, you may want to put a 1 in front of the SF4 and the S2CL2 on the assignment, because they're not there, and I don't want you to get confused. So this is not the first time you've seen this exact slide. It's been multiple days that I've shown this to you. If you are going from grams of one thing to grams of something else, it will be a 3-step mass-mass. And both of these on here are 3-step mass-mass. I would circle these 2 1s because they are always a 1. This, I don't know. This depends. If it has a 1 in front of it in the balanced equation, it gets a 1. If it's got a 16 in front of it, it gets a 16. So moles to grams of the same substance is a 1-step molar mass periodic table problem. Moles to moles of different substances is a 1-step mole using the balanced equation. Put a gram of one thing to a gram of a different thing is always a 3-step mass. And that is your template. Okay. We're going to work through a problem. We have zinc reacting with chlorine gas to produce zinc chloride.
So what were the questions on the
Did I miss something? To answer your mass, the answer to a mass problem is are you talking about those 2? The answer to your mass, let me go backwards. The answer to the mass is the theoretical yield. And normally, which one?
It's like the one, like, how do you go between moles?
Okay. How to go between moles and grams, which is mass, is using a molar mass, which is the periodic table. To go between moles of different substances, you use the coefficients from the balanced equation. Like I said, if it's a mass, the second one, if you go between moles of 2 different things, you use the coefficients from a balanced equation. And I'm pretty sure most of your, if not all of your equations are balanced on the test already. I'll have to go back and double check. We will review on Thursday. I will let you use the review on the test. It's really gosh darn similar to the test. It's just not the same equation or the same amount for the starting substance. It's the same process. All right, we're going to go through this problem. It is already balanced. They're all 1s. Every now and then you come across a skeleton that doesn't have to have any extra coefficients put in. It says you begin with 58.9 grams of zinc, and you have excess chlorine. If something is in excess, is it important? From what we did yesterday and before, if it's in excess, Does it matter in the math? No. If you see something's in excess, don't let it throw you off. That is not going to be part of my math. Now, if you have to determine the limiting reagent, that's when you have to figure out who's limiting, who's in excess, and then you're going to use the limiting to run your problem. I want to know what the theoretical yield of zinc chloride is in grams. Okay, so my math is going to tell me my theoretical yield. Then it goes on to say, if you isolate 115 grams of zinc chloride, what is your percent yield? Before I can use this, I have to figure out how much of this I should be able to make. This is how much I make. But I have to do a 3-step mass to calculate my theoretical, and then it is your actual divided by your theoretical times 100 is your percent. So I'm starting with 58.9 grams of zinc. I don't want to be in grams. If you're in grams, the only thing you can change it to is 1 mole of that substance. I know that's going to be a 1, but I always drop my numbers in last. That's awesome. I don't want to be in moles of zinc. I want to be in eventually grams of what? The zinc chloride. So I can't go to grams directly from zinc because this isn't zinc. So I have to go to moles first, which it's not going to really make a difference because there are ones. But then I can go from 1 mole of what I'm changing it into, my unknown, into grams. Zinc is easy. We just pull it straight off the periodic table. 65.38. Once again, that's the bottom number inside the block. My coefficients happen to both be 1s. It doesn't change anything. And then I have to do 65.38 plus 2 times 35.45. And that ends up being 136.28, as long as I didn't mess up anything when I was calculating this last weekend. I don't think I made any mistakes. You guys know you're my first chemistry, you get to catch all of them. I know everything's gonna cancel. Earth space, first and second. I don't have a third, that's why I'll do. So I'm trying to grade, and if I gotta call parents or make copies, or in the case of Earth space, trying to make my Cenozoic notes. So the ones don't affect anything. And I just didn't cross them out. You can cross them out if you want to. You would do 58.9 times 136.28 divided by 65.38. I am going to round it to 3 numbers total. So it's going to round to 123 grams. That's my theoretical yield. That's what TY stands for. If I was just asking for this, you'd be done. But there's a second half to this question. You make 115 grams of the zinc chloride. And if you make that amount, and this is how much you should have, then by comparing these to each other times 100, we'll change it to a percent. And you should always give 2 numbers after the decimal of a percent. Yes. Sure, you got a good angle. You can't get this one opened. Okay, are y'all done with this one, or are you starting? Hold on, okay. Because I have to go to the next slide to finish the problem. I can't stick it all up on one slide. All the letters and stuff would be too small. Let's see who else is not here. Yep, that's the theoretical yield. That's if you're 100% perfect, which nobody is. That's how much you should be able to make. But that's not how much you make. You make 115. So, same problem. This is your actual yield. The answer from the previous one, 123 grams, was your theoretical yield. And the formula for this, for percent yield, would be the actual divided by the theoretical, and then that decimal times 100. So plugged in it'll be from the problem, which is gonna be the smaller number. Now, if this is larger than what you calculated, then you did something wrong. Whether it was a measurement issue when you were doing the lab itself, or maybe you didn't use the right molar masses, which is most often the thing, or you didn't have a correctly balanced equation. This is what makes chemistry hard, is there's so many little things that we may have to ask you to do. But in this case, when I multiply by 100, I have a percent yield of 93.50%, which is pretty gosh darn good. I can't remember what my percentage was when we made aspirin. I remember that lab being horrible. Huh? No, they don't let us, they didn't let us keep it. We have to dispose of everything. Okay, seriously, this is all I really need to show you for percent yield. Now, these two problems, like I said, if you need to, put a 1 in front of the SF4 and the S2Cl2 because they're not there, so that means that they're a 1. Don't the review things at the bottom of these papers are part of the grade. I have a lot of people that are doing the top part and not doing the bottom part, and they're getting that mark wrong. Now, we have over 20 minutes in class. Are there any questions with the percent yield? It's the 3-step mass. It's the same thing we've been doing. Now all you're doing is you're taking how much you make divided by your answer to your math times 100, and that's your percentage. If you get more than 100%, you've either flip-flopped them or you messed up your math. Let me stop this.